a middleware architecture for resource-oriented systems. Following is the topic that I'll be discussing through my talk. So now we come to the question that I'm trying to answer through this paper or whatever research I did in my PhD. The question is, how do we make the consumption of RESTful web services simple, scalable, and secure when we are delivering it to the mobile clients? Here's an architecture of the current state of art that how we consume RESTful web services right now. So as you can see on the right-hand side, that's a RESTful web service implemented using, there are the resources that it offers. So the person, a client smart mobile device in this case, can access those resources using a uniform interface. So the characteristic of RESTful web service is that it exposes all the services using a uniform interface. Based on the current architecture, I identified three main challenges with this approach. One is reduced system performance. As we know, the mobile clients, due to the limitation of bandwidth, they cannot consume resources very quickly. So there's a problem of bandwidth. So the response time is quite low when we are consuming resources. So which actually affects the overall system performance. Secondly, there's an increased client load because most of the services are now offered as a combination of services. So it's called mashups, combination of services. But the CPU of mobile devices doesn't offer that kind of power to consume such services. So there's an increased client load. And lastly, as we know that in a REST system, if the person has a UI to the resource, he or she can invoke any kind of operations on the resource, which can also lead to security issues. The person can change the resource which is not expected to be changed. So in order to tackle these challenges, I started surveying the literature by looking at the web services. According to the current state of the art, there are two competing styles of implementing web services. One is REST, and the second is WS star, sometimes also called a SOAP. WS star stands for Web Service Technology Stack. And based on the previous feature, the research done by other people, I found out that RESTful web services is the ideal way to go when we are consuming web services through mobile clients. Well, you may ask, what is REST? REST is actually an architectural style for distributed hypermedia systems, which was first introduced by White Building in his doctoral dissertation. REST follows four basic principles which make it superior to SOAP or WS star. In REST, everything is considered a resource. Everything which you can name as a noun is considered a resource and is assigned a URL. The resources in REST are stateful. They carry the state of the system, but the communication between the client and the server is kept stateless, which allows for high scalability. And it also allows multiple representation, so you can return XML, text, HTML, whatever the client wants. Secondly, when I was looking for scalability and security, I surveyed the literature of a WS star system. So I asked a question that what makes them scalable and secure in case of enterprise, because most of the WS star systems are implemented in enterprises, and they are highly scalable. So I found out that they actually use a middleware architecture called Enterprise Service Bus, which make them such. But I couldn't find any such architecture for REST-based systems. And our lab is currently working, as you have seen in the presentation of Hashim, that we are working on a proxy. So that is also part of my research. And lastly, I looked into the concept of databases, the concept of views in databases. You may ask, what is the relation between databases and a RESTful system? Actually, they share a basic concept, which is at the core of both the systems. It's actually, they are both state dependent. So I wanted to use the view concept in databases to apply to REST systems of how we can make views on resources. This is a proposed architecture. As you can see, the enterprise resource bus is hosted in a cloud for high scalability of the system. And it has three main components. One is proxy server, which handles the request for the client, and it also handles the communication between various components of the enterprise resource bus. secondly, there is a routing database which actually contains the information about the URL, so where to route the request to. And lastly, there is a view repository, which actually manages the defined views on resources. It also caches the previous responses under the client. So you can supply the resources very quickly when creating system performance. Next question is, how do we define views on resources? I identified two main ways in order to define views on resources. One is the virtual resource. A virtual resource is a view defined on a single resource. As you can see in the figure here, a system administrator would have to define a generic resource or a generic view, which is associated to or group of all the set of resources that it can apply to. And then a simple invocation of the generic resource, a virtual resource, say R1 dash, can be generated for R1. Similarly for the composite resource, it's actually a view defined on a set of resources. So if you want to have a composite resource, there is a view for R1, R2. So similarly, it can be generated on the fly. Here's an example scenario where our system can be useful. We didn't do implementation yet. This is a novel, just the introduction of the architecture, conceptual view. In the first case, you can see a BlackBerry client when issues a request to resource R1. The enterprise resource plus intercepts the request, and it checks that whether this client has access to that resource, but it finds that it doesn't have access to that resource. So it provides a partial view of that resource, that is R1. So it returns R1 dash. So that is a virtual resource. Similarly, in the case of a tablet here, which has more processing capabilities, so it can process and mashup. So it returns R2 R3, that is a composite resource. To summarize, the main highlights of my work is that I introduced Enterprise Resource Plus, which is a novel middleware architecture for resource-oriented systems. Secondly, the concept of views on resources was introduced for the first time for REST systems. And well, I cannot support my claims with the data yet, but I can say that with the help of Enterprise Resource Plus, we can increase system performance, security, and have better client models. And in the future, I propose to implement the proposed architecture and to test my claims and support it with the data. So I will be implementing the architecture and probably will be expanding my architecture to include more functionalities of enterprise services. Thank you. Any questions?
So, what did you use in your system? What security measures did you use in the system?
For security measure, as we consider the views in databases, views in databases actually limits the user access to particular data, right? So in the same case, I'm using the same concept for views on resources. So the person who doesn't have access to the data we will provide the view to that person. So he cannot actually access the full resource. So that is actually, we are enforcing the security on that resource.
Was your idea of the concept of the view, I didn't quite understand it, but is it something like the idea of views in databases or more like views in model view controller?
No, it's actually views in databases. Any questions?
Strong question. Can you just explain the stateful resource? What do you mean by the state of the resource?
Okay. Yeah. In REST, the principle is that every resource contains a state. So sometimes we also call it hypermedias and application state, which is the least understood concept in REST. So that actually means that when a server communicates with a client wants to access a particular resource, the client provides all the data that the server provides all the data that a client can do next. So all the functionality will be provided within the resource. So no resource, that means like, if you consider the example